All right, today we're going to talk about how we can transform quadratic functions. And let's first talk about a vertical transformation. This is all pretty easy stuff, but it's very important. It'll help us on the end of course exam. If we graph our parent quadratic, let's say that we graph plain old x squared. Looks like that. The vertex is down here at 0, 0. All right? We've been working with vertex and maximums and minimums and so on. But if you see f of x equals x squared plus 3. So what did we do to the original function? We just tacked on a plus 3. If you see that, then this graph right here goes up 3. The vertex goes up 3 units. Up 1, 2, 3. Pretty simple, right? If I had x squared minus 3, it's what you think it is. It would go down 3. So that function would have a vertex. Now the vertex is down here at 0, negative 3. So the vertex or the minimum has moved down 3. We call that a vertical transformation, up or down. All right? Now let's talk about and one thing I want you to notice about these, before we talk about horizontal, is I want you to notice that the plus 3 and the minus 3 are not inside of parentheses. All right? So there's no parentheses on this. When the plus 3 or the minus 3 is outside of parentheses, it's up or down. Now let's talk about horizontal transformations. All right? And what I want you to kind of note about horizontal transformations is they are inside. When I say inside, I mean inside parentheses. And opposite. They are inside and opposite. So when we deal with a horizontal change, let's sketch our parent x squared function again. Once again, our vertex is down here at 0, 0. If you see a quadratic function written this way, f of x equals x minus 2, the quantity squared, now it has some parentheses, and we have this minus 2. Remember what I said about it being opposite? You would think this minus 2 would mean it would go to the left 2, but it's the opposite of what you think on the horizontal transformations. This is to the right 2. So this quadratic would now have a vertex over here 2 units to the right at 2, 0. All right, vertex moves to the right. And that also means that if you had one like this, x plus 2 quantity squared, remember, think opposite when it's inside. This is going to go to the left 2. So this one has a vertex over here at -2. Vertex over on this one is negative 2, 0. All right? So we've talked about vertical transformations. Vertical transformations, the change is just added or subtracted on the outside. When we have a horizontal change, we have our change inside parentheses, but it's moved the opposite way you think it is. All right? Now, we've also seen, as we've studied vertexes, that there could be a time where the graph is upside down. We call that a reflection. All right? And this is really easy. If our normal graph of x squared looks like this, in other words, it's facing up, what happens to the function itself to make it face down? We just put a negative in front of it. If I have negative x squared, and you should have noticed this when we were doing that work the last couple days, it's upside down. The moment I put this negative in front of the x squared function, in front of the quadratic, it makes it upside down. Always. All right? One last thing. Stretch and shrink. Once again, let's sketch our regular old x squared function. Here's f of x equals x squared. Now what we haven't talked about is we could stretch this function, make it skinnier, by multiplying it by something bigger than 1, like 3x squared. If I multiply by something bigger than 1, it stretches the graph and makes it skinnier. All right, we call that this is called a stretch. You need to be familiar with that term. It's called a stretch. And yes, its vertex would still come all the way down to 0, 0. So if this number in front of x squared is bigger than 1, and remember, that could look a lot of ways. What if I had the fraction, what if I had 5 halves x squared? That would still be a stretch, because 5 halves is the same thing as 2 1/2. All right, this is still a stretch. Now, what's the opposite? The opposite is what we call a shrink. And that happens when we multiply by something less than 1, like 1/2 x squared. And a shrink kind of squishes the graph, like this. All right, on a shrink, your graph is now wider. All right, it's been kind of compressed, squished, so to speak. And that is when this number out in front is less than 1. And remember, that could be a decimal. That could be like 0.3 x squared. That is also a shrink. If this number in front is less than 1, it's a shrink. If this number in front is bigger than 1, it is a stretch. And we will stop there for today.